Businesses operate on a constant flow of data. This is the domain of network engineering, dedicated to designing, building, managing, and securing the digital highways that connect our world. At its core, network engineering encompasses the entire life cycle of a data network. It blends technical knowledge with strategic foresight to create robust digital foundations. Modern network engineers are at the forefront of cybersecurity, protecting sensitive data. Their work forms the indispensable backbone of our digital society. We are living in an era of unprecedented digital transformation. Businesses are shifting to online platforms, placing immense strain on digital infrastructure. Network engineering has transformed into a core strategic driver. A robust, secure, and scalable network is the fundamental prerequisite for survival. The COVID-19 pandemic highlighted the importance of corporate networks. Furthermore, the explosion of data elevates the importance of network engineering. Finally, the escalating threat of cyber attacks has placed network security at the forefront. Network engineers play a crucial role in building the first line of defense. Network engineering viewed strategically enables key corporate objectives. A fast, reliable network enhances operational efficiency and ensures employees have instant access to information, improving collaboration and agility. A sophisticated network architecture is fundamental to delivering an exceptional customer experience and drives revenue growth. Strategic network engineering unlocks innovation and future growth. A well-architected network is critical for risk management and business resilience, protecting revenue and stakeholder confidence. To harness the strategic power of network engineering, industry leaders must understand its key components. This guide demystifies networking, providing data-driven insights for informed decision-making. We'll explore educational pathways, certifications like Cisco Certified Network Associate, and the blend of technical and soft skills needed for a top-tier network professional. We will also delve into core job roles, including network administrator, engineer, and architect. Finally, this essay will provide a comprehensive analysis of the network technology marketplace. Supported by current market share data and industry reports, this analysis will equip leaders with the knowledge needed to evaluate potential partners. A formal degree provides the theoretical knowledge necessary to grasp the complex principles that underpin modern networking. A Bachelor of Science in Computer Science, Information Technology, or a specialized field like telecommunications or computer engineering is a common starting point. These programs offer a comprehensive curriculum covering fundamental concepts. Coursework often includes dedicated classes on computer networks, where students learn about the OSI and TCP/IP models, IP addressing, routing protocols, and switching fundamentals. It develops critical thinking and analytical problem-solving skills. Finally, for those aspiring to leadership roles like network architect, a postgraduate degree can be a significant advantage. It equips professionals with the strategic foresight and advanced knowledge required to design complex network infrastructures. Industry certifications are the gold standard, demonstrating expertise with specific technologies. Certifications like CompTIA Network Plus validate fundamental networking concepts. Cisco offers a respected certification track, starting with CCNA, demonstrating proficiency in network operations. Higher-level certifications like CCNP and CCIE signify deep expertise. A well-rounded team possesses a mix of credentials, reflecting expertise across different platforms. Supporting employees in pursuing certifications is a direct investment in organizational capabilities. Technical proficiency is the bedrock, but not the sole determinant of success. Soft skills are equally critical. Communication is paramount. Engineers must explain complex issues to non-technical stakeholders. Problem-solving is indispensable, involving analytical thinking and persistence. Engineers must remain calm under pressure, systematically investigate, and think outside the box. Meticulous attention to detail is non-negotiable. Successful engineers are methodical and precise. Strong collaboration and teamwork skills are essential. An engineer who can work effectively as part of a team becomes a force multiplier. Network administrators are at the operational core of IT, maintaining the health and stability of the network infrastructure. They are the guardians of day-to-day operations, ensuring the company's digital highways remain open and efficient. Their primary responsibility is to manage and monitor the network, proactively identifying potential issues. They troubleshoot connectivity problems, manage network equipment, and implement user access policies. They also handle routine maintenance and manage network security. This constant cycle is critical for keeping the network secure and stable. Providing them with the right tools is a strategic investment in the reliability and security of the entire organization. While administrators maintain the present, network engineers are responsible for building the future. This role is more project-focused, centered on the design, implementation, and expansion of the network infrastructure to meet evolving business requirements. When a company decides to open a new branch office, integrate a new cloud service, or upgrade its core network to support higher bandwidth demands, it is the network engineer who translates these business needs into a technical reality. They are the architects of connectivity, responsible for creating detailed network designs that are scalable, resilient, and secure. This involves selecting the appropriate hardware, designing logical and physical topologies, and planning for future growth, ensuring the network can support the company's strategic goals. The work of a network engineer is a blend of high-level design and hands-on implementation. After creating a comprehensive design plan, they lead the process of building and deploying the new network segments or systems. This involves the physical installation of routers, switches, access points, and firewalls in data centers and wiring closets. Following installation, they perform the intricate configuration of these devices, implementing routing protocols like OSPF or BGP, setting up VLANs to segment traffic, and establishing security policies. They conduct rigorous testing to ensure that the new implementation performs as designed and integrates seamlessly with the existing network, all while carefully managing the project to minimize disruption to ongoing business operations. Network engineers also play a crucial role in performance optimization and capacity planning. They analyze long-term traffic trends and performance data to identify potential bottlenecks or areas where the network is approaching its limits. Based on this analysis, they recommend and design upgrades to enhance performance and increase capacity. This proactive approach ensures that the network infrastructure does not become a constraint on business growth. Whether it involves upgrading the internet backbone, implementing quality of service policies to prioritize critical application traffic, or redesigning a portion of the network for better efficiency, their work is essential for ensuring the network can handle future demands and support new technological initiatives. From a leadership perspective, network engineers are key strategic assets who directly enable business agility and expansion. They are the bridge between business objectives and technical infrastructure. Investing in a strong engineering team means the organization has the in-house capability to adapt its digital foundation quickly in response to market opportunities or competitive pressures. Whether it's facilitating a merger by integrating two disparate networks or enabling a new digital service for customers, the expertise of network engineers is what makes these strategic moves possible. Their ability to design and build robust, high-performance networks is a direct contributor to the company's competitive advantage and long-term success. The network architect is the visionary responsible for creating the long-term blueprint for an organization's entire network ecosystem. They evaluate emerging technologies, anticipate future business needs, and design a robust and scalable network strategy aligned with company objectives. The primary deliverable is the enterprise network architecture, a master plan that governs the network's design and evolution. Collaboration with senior business leadership is a fundamental aspect of the role. For any forward-thinking organization, the network architect is an indispensable leader, ensuring the network drives the business forward. As network environments grow in complexity, specialized roles have emerged to address specific, high-stakes domains. The network security engineer is one of the most critical of these specializations. This professional focuses exclusively on protecting the network from cyber threats. Their responsibilities go far beyond standard firewall management. They design and implement comprehensive security architectures. This includes deploying advanced security solutions like intrusion prevention systems, web application firewalls, and secure access service edge frameworks. They conduct regular vulnerability assessments and penetration tests to identify and remediate weaknesses before they can be exploited by malicious actors, serving as the network's dedicated defender in an increasingly hostile digital world. The network security engineer works in close collaboration with the broader cybersecurity team to develop and enforce security policies across the entire organization. They are experts in network forensics, capable of analyzing traffic patterns and logs to investigate security incidents and determine the scope of a breach. They also design secure connectivity solutions, such as site-to-site virtual private networks and remote access systems, ensuring that data remains encrypted and protected as it traverses untrusted networks like the internet. In an era where a single data breach can cost a company millions and cause irreparable reputational damage, the expertise of a dedicated network security engineer is not a luxury, but an absolute necessity for effective corporate risk management. Another highly sought-after specialist is the cloud network engineer. With the massive corporate migration to cloud platforms like Amazon Web Services, Microsoft Azure, and Google Cloud, a new set of networking challenges has emerged. The cloud network engineer specializes in designing, building, and managing the network infrastructure within these cloud environments. This involves configuring virtual private clouds, setting up complex routing between on-premises data centers and the cloud, and managing cloud-native networking services. They ensure that applications deployed in the cloud have the same level of performance, reliability, and security as their on-premises counterparts, bridging the gap between traditional and cloud-based infrastructure. The role of the cloud network engineer is crucial for any organization leveraging a hybrid or multi-cloud strategy. They are responsible for optimizing network performance and cost within the cloud, which involves selecting the right services and configuring them for maximum efficiency. They also play a key role in automating network provisioning and management using infrastructure as code tools like Terraform or CloudFormation. This automation accelerates deployment, reduces human error, and allows the business to scale its cloud presence rapidly and reliably. For industry leaders, investing in these specialized security and cloud networking roles is essential for navigating the two biggest transformations in information technology: the rising tide of cyber threats and the strategic shift to the cloud. Network engineers proactively monitor network performance using sophisticated tools. They also plan and execute routine maintenance, including updates and hardware checks. This ensures network stability and security. This daily watchfulness creates a reliable network environment, preventing costly downtime and supporting business operations. Network engineers must precisely configure devices using complex interfaces. Accuracy is critical. Even minor errors can cause significant issues. Changes require formal documentation, review, and approval. Engineers maintain detailed documentation, including network diagrams and procedures. This documentation is invaluable for troubleshooting and deployment. Configuration, change management, and documentation embody the discipline of precision. This separates a professionally managed network from a chaotic one. It builds a reliable foundation for business operations. Despite proactive efforts, network issues are inevitable in complex environments. When problems occur, engineers troubleshoot systematically to restore service quickly. This involves defining the problem, gathering data, and forming a hypothesis. Testing the hypothesis in a controlled manner is crucial to isolate the fault. It requires technical knowledge, experience, and persistence. Effective collaboration is essential as network issues can stem from various sources. Post-mortem analysis helps prevent recurrence through continuous improvement. In the global financial industry, the network is the marketplace. Trillions of dollars are exchanged daily across global networks. In this high-stakes environment, speed is a primary currency. A delay of a single millisecond can mean the difference between profit and loss. Beyond speed, reliability is paramount. Unplanned downtime can trigger catastrophic financial losses. Security is an area of intense focus, given that these institutions are prime targets for sophisticated cyber attacks. Finally, network engineering is critical for ensuring regulatory compliance. In the healthcare industry, the value of network engineering has shifted from administrative support to a critical component of patient care and safety. Modern hospitals and clinics are hubs of digital activity, with electronic health records, high-resolution medical imaging from MRI and CT scans, and real-time patient monitoring systems, all generating massive amounts of data. A robust and reliable network is essential to ensure that physicians and nurses have instant access to this life-saving information at the point of care. A network delay could mean a critical delay in diagnosis or treatment. Network engineers in healthcare design highly reliable wireless and wired networks that guarantee seamless connectivity throughout a medical facility, from the emergency room to the operating theater. The rise of telehealth and remote patient monitoring has further amplified the importance of sophisticated network infrastructure. During and after the pandemic, virtual consultations became a mainstream component of healthcare delivery. This requires secure, high-quality video and data connections between patients' homes and healthcare providers. Network engineers are responsible for building the secure VPNs, managing the bandwidth, and implementing the quality of service policies necessary to support these services. They are enabling a new model of distributed care, allowing for continuous monitoring of chronic conditions and improving access to medical expertise for patients in rural or underserved areas, which fundamentally changes how healthcare is delivered. Security is a particularly acute concern in healthcare networks due to the sensitive nature of patient data. Protected health information is highly valuable on the black market, making healthcare organizations a prime target for cybercriminals. A breach can lead to devastating privacy violations and massive regulatory fines under laws like the Health Insurance Portability and Accountability Act. Network engineers are tasked with designing and maintaining HIPAA-compliant networks. This involves implementing strong encryption for data in transit, segmenting the network to isolate sensitive patient data from less secure areas, and deploying advanced threat detection systems to guard against ransomware and other malicious attacks, thus protecting both patients and the institution. Furthermore, network engineering is the backbone for medical innovation. The Internet of Things is transforming hospitals with smart devices like connected infusion pumps, real-time location tracking for equipment, and wearable sensors for patients. These technologies promise to improve efficiency and patient outcomes, but they require a network that can securely support tens of thousands of connected devices. Network engineers must design scalable and secure networks capable of handling this massive influx of IoT traffic. Their work provides the foundational platform upon which the future of connected data-driven medicine is being built, enabling smarter, safer, and more efficient patient care for everyone. Network engineering has become the central nervous system of the modern factory, powering Industry 4.0. Thousands of sensors are constantly monitoring machinery, and automated robotic arms perform complex tasks. Network engineers design this critical infrastructure, ensuring seamless data flow. The network is fundamental to achieving operational efficiency and predictive maintenance. AI algorithms forecast machinery failure, enabling proactive maintenance and avoiding downtime. Network engineers design resilient networks and secure OT networks, protecting critical systems. Network engineering enables connected supply chains, sharing real-time data with global partners. In the fiercely competitive retail industry, network engineering is the invisible force behind the modern customer experience. From point-of-sale systems to e-commerce platforms, every interaction is powered by the network. A slow network leads to frustrated customers. Network engineers design and manage the networks connecting stores and distribution centers, ensuring a smooth experience during peak seasons. They deploy robust networks and ensure data flows between all retail channels. The network is the critical link in supply chain management, providing visibility over the global flow of goods. Data analytics, powered by the network, transforms how retailers understand and interact with customers, enabling personalized marketing and accurate demand forecasting. Network engineers build scalable networks for data collection, enabling data-driven strategies for a competitive edge. The world of network engineering relies on specialized hardware and software. Key companies design and support routers, switches, and security appliances. Understanding these players is essential for leaders making infrastructure decisions. Companies like Cisco, Juniper, Arista, and Huawei offer vast product portfolios. Each provides an ecosystem of hardware, operating systems, and management software. Choosing between them means investing in a partner's long-term vision. This section profiles major players, exploring their technologies and adaptation to trends like cloud computing. Understanding each provider's unique value is the first step towards strategic decision-making. Cisco Systems has long been the undisputed leader in the networking industry. For decades, its name has been pretty much synonymous with the routers and switches that power the internet. The company's strength lies in its incredibly broad and deep product portfolio, which covers nearly every aspect of enterprise and service provider networking. Its Catalyst series of switches are a staple in corporate campus networks worldwide, providing reliable connectivity. In the data center, its Nexus line of switches offers high-performance, scalable solutions. Cisco has also heavily invested in software and security, acquiring numerous companies to build out its offerings. Cisco DNA Center provides a centralized management dashboard that allows administrators to design, provision, and apply policies across the entire network from a single interface. For C-suite leaders, Cisco represents a stable, reliable, and comprehensive choice. Cisco's strategy is to be the one-stop shop for all networking and security needs. Juniper Networks entered the market as a challenger to Cisco, focusing on high-performance hardware for service providers. Its DNA is rooted in carrier-grade hardware designed for scale and reliability, all running on its Junos operating system. Products like the MX series and QFX switches compete with Cisco and Arista. Juniper emphasizes engineering excellence and operational simplicity. Its AI-driven vision, enhanced by the Mist Systems acquisition, simplifies network operations. Juniper offers a compelling value for organizations seeking intelligent, proactive networks. While smaller than Cisco, Juniper is a strong competitor with a clear vision for automated networks. Arista Networks emerged as a disruptive force, founded by networking veterans, building high-performance switches for massive data centers. Arista's core innovation is its extensible operating system, or EOS, built on a Linux kernel. This makes EOS highly programmable, customizable, and resilient. The company's product line consists primarily of high-density, low-latency Ethernet switches. Arista's primary software platform, CloudVision, provides centralized control for network automation. Arista represents the pinnacle of performance, openness, and programmability for the data center. Choosing Arista is a strategic decision for businesses where the data center is a core competitive asset. Huawei Technologies is a global technology giant based in China with a diverse product portfolio. Within networking, it offers a complete range of products. Huawei's advantages are its R&D budget and end-to-end solutions. The company has a strong presence in Asia, Africa, the Middle East, and parts of Europe and Latin America. Huawei is a global leader, particularly in 5G. However, geopolitical tensions, particularly with the US and its allies, have impacted Huawei's ambitions. This has created a fractured global market, a situation unique among major networking vendors. The decision to consider Huawei is a strategic one for the entire C-suite. When evaluating network providers, understand their core strategic philosophies. Cisco aims to be a single vendor for every networking need, creating a powerful ecosystem. Arista Networks focuses on specialization and openness, particularly in data centers. Their Linux-based system promotes programmability. Juniper Networks balances engineering with AI-driven simplicity. Built around its Junos operating system, Juniper simplifies training and automation. Huawei seeks global market leadership through scale and R&D. Their strategy is to compete directly, offering a cost-effective alternative. This makes the decision complex, weighing capability, cost, and geopolitical risks. The Network Operating System, or NOS, defines a network hardware's features. Cisco's iOS is a long-standing industry standard known for its maturity and stability. Arista's EOS, built on Linux, is open, modular, and programmable, offering resilience through process isolation. Juniper's Junos OS provides a middle ground, with a structured design and consistent experience across its product line. Huawei's VRP competes with Cisco iOS, offering a mature platform, though its ecosystem is still developing in Western markets. The new frontier in networking is all about smarter software automation and AI. Cisco's DNA Center automates network policy and management but works best in all Cisco environments. Juniper's Marvis uses AI to proactively fix network issues and answer admin questions in plain English, making IT operations simpler. Arista's CloudVision and open APIs let customers build custom automation with DevOps tools, focusing on flexibility over a single AI controller. Huawei's iMaster NCE offers advanced automation and AI, especially for service providers, but its reach is limited outside its core markets. Each vendor's automation strategy reflects its broader vision: integrated control, AI-driven operations, open programmability, or end-to-end intelligence. The race is on to make networks not just faster but truly self-driving. Security is a make-or-break factor in choosing a network partner. Cisco embeds security everywhere: firewalls, DNS protection, and unified threat response, offering a one-stop solution. Juniper's connected security turns every network point into a security checkpoint, automating threat response across its ecosystem. Arista focuses on micro-segmentation and integrates with top security partners, giving customers flexibility and deep visibility. Huawei's HiSec suite uses AI for threat detection, but faces adoption barriers in Western markets due to security concerns. The right security approach depends on your risk tolerance, regulatory environment, and need for integration or flexibility. In today's landscape, security isn't an add-on, it's the foundation. Picking a networking vendor is a strategic partnership. Align it with your needs and goals. Cisco is the safe, integrated choice for enterprises seeking stability and support. Arista excels in high-performance, programmable data centers for tech-driven organizations. Juniper offers AI-driven operations and efficiency, ideal for proactive, automated management. Huawei delivers advanced tech at scale, but geopolitical risks limit its appeal for multinationals. The best partner is the one whose strengths match your vision and your risk profile. The Ethernet switch market is a key indicator of networking's competitive landscape. Cisco dominates with 40–45% share, especially in enterprise campus networks. Arista leads in high-speed data center switching, capturing over 20% in 100G+ segments. Huawei is strong globally, but mainly outside Western markets. Juniper holds steady single-digit shares. The fastest growth is in high-speed ports for AI and cloud, while legacy speeds stagnate. The data is clear. Future-proofing means investing in faster, smarter networks. Align your strategy with where the market and your business are headed. Routers power everything from branch offices to global telecom backbones. Cisco and Juniper lead in service provider networks, with Huawei dominating in Asia and emerging markets. In enterprise routing, South Dakota, WAN is disrupting the old guard. Software and security now matter more than hardware. Cisco remains strong but faces competition from Fortinet, VMware, and HPE in SD-WAN. For service providers, vendor choice is a long-term ecosystem bet. For enterprises, it's about software agility and security. Market share is shifting toward those who integrate automation and security into their platforms. The future of routing is software-defined, secure, and cloud-ready. Industry data points to key trends shaping network infrastructure spending. Capital expenditure on AI-driven data centers is a significant driver. This requires AI fabrics to handle massive traffic with low latency. AI workload switch revenue could reach over $10 billion annually, benefiting vendors like Arista and NVIDIA. In campus networking, the shift to software and subscriptions continues. Software revenue for management and security will grow faster, driven by platforms like Cisco DNA Center. There's a strong emphasis on wireless networking, with Wi-Fi 6/6E/7 outpacing wired growth. A wireless-first mindset is now essential for modern campus networks. The network is now a core strategic asset, enabling growth and innovation. Building a capable network engineering function requires technical skills and soft skills. This delivers value across diverse industries like finance, healthcare, manufacturing, retail, and logistics. A high-performance, secure, and reliable network is essential for operational excellence. Understanding the different value propositions of network service providers is crucial for leaders. Cisco's dominance persists, but there's fierce competition and rapid growth in specific segments. Strategic investments must be directed toward higher speeds, intelligent automation, and a wireless-first approach. Looking toward the horizon, the future will be defined by intelligence, automation, and disaggregation. The network of tomorrow will be increasingly autonomous, leveraging AI to predict and prevent problems. This will reduce operational friction, freeing engineers to focus on innovation. For industry leaders, this means embracing platforms that deliver a resilient, self-optimizing network experience. The imperative for automation will continue to intensify, evolving to a net DevOps culture. Furthermore, disaggregation, which separates hardware from software, will continue to gain traction. In conclusion, the role of network engineering has ascended to a C-suite level strategic concern. Embrace intelligent, automated, and open networks. Organizations can build a powerful competitive advantage in an increasingly connected world.